Hey everybody, welcome back to the Adventures of Blink. I am of course Blink, and you can find me on GitHub right here. Today I've got something super exciting in store for you. We're going to dive into the world of Retrieval Augmented Generation, or RAG for short. We're going to build a RAG app using Ollama and ChromaDB. And for an extra twist, we'll be using our app to process YouTube video transcripts. We'll walk through the entire process step by step. So whether you're a seasoned developer or just getting started, there's something here for you. By the end of this video, you'll have a powerful app that can enhance your data retrieval and processing capabilities. And hopefully I spark some interesting thought in your head for a creative way that you could use this above and beyond even what I've shown. So grab a cup of coffee and get yourself comfortable, and let's dive into this adventure together. Don't forget to like, subscribe, and hit the bell icon so you never miss an update. All right, so before we dig into the technical details today, I want to take a moment and acknowledge the person who's provided us with inputs. So my friend Shreya Gupta is a developer advocate at Okta, but she runs a YouTube channel here called the Developer Diaries. I'll put the link up here for you. The Developer Diaries is effectively a collection of stories, interviews that she's done with different developers to sort of figure out how it was they became a developer. We didn't all get here by deciding to be one day. Some of us took some really non-standard approaches. So the episode that I picked as an input for the process here that we're building is the third in a series she did with Craig Dennis, who is another good friend of mine, a developer educator over at Cloudflare. Now, Craig's an awesome guy. If you've ever seen any of his work, he's all over the place teaching people how to use tech. One of my mentors, one of the folks I look up to on a daily basis. But I thought it would be fun for us to sort of quote unquote collaborate by grabbing their interview and using that as the input to see how our RAG app works today. So we're going to check that out. I hope you'll go check out Shreya's channel and get to know both her and Craig through that. So our goal for today is to build a tool that helps us with some of the tedious work involved in producing a YouTube video. Filming the video and editing it is kind of the fun part. But then you have to think of all those other little things that go into the process, like choosing your title and making sure you have a good description with lots of relevant keywords, that you've got the right hashtags on it so that the YouTube algorithm picks it up and shows it to enough folks that might be interested. Furthermore, you're going to want to do things like find key moments in the video that you would make into YouTube Shorts or Instagram Reels or TikToks to promote your video even further across multiple platforms and bring people back to YouTube to see what it is that you've built. That's a whole lot of work. I can tell you from experience that it's time consuming. Like, you can get lost in it and it takes a while. So why don't we build an AI-powered tool that does some of that for us? Does that make sense? Well, let's dive right in, shall we? So the first thing we need to do is talk a little bit about Retrieval Augmented Generation. That's a really fancy sounding term, but what is it? To understand it, we probably need to start at the end of the process and sort of draw our way back to the beginning. So we have some questions that we want answered, right? And the way we intend to answer these questions is to build an app, because that's what good developers do, right? We solve problems with code. So we're going to write a Python program that answers these questions. Well, that's cool, but where does our Python program get its answers from? How does it know how to answer whatever questions we're going to throw at it? Well, because you've heard me talk about this being AI related and we're talking about large language models for the last few weeks, you're probably imagining that there is an LLM involved in this process someplace. And so yes, we are going to have an LLM that's going to feed our Python program. But there's a limitation. That language model probably wasn't trained by us. It probably wasn't trained on any of the data that we actually need to use to answer the questions. And so how is the model going to know what answers to give us other than just making things up? Well, we need to provide that data. And so what we're going to do is we're going to create a Chroma database. Now, Chroma allows you to build an in-memory database. This is not something that goes to disk. It stays in RAM for the entirety of its existence. It's a quick place to construct the information and put it in place where it can be used by a language model. We'll talk a little bit more about the details as we go through the code, but out of the gate, that's where we're starting this journey. And so we're going to plug that data in, and it's going to join up right here in this little spot where we're going to have sort of this intersection of an LLM up top and the Chroma database from the bottom. They're going to come together and feed the data into the Python program so that it can create the output we want. Okay, and we're going to populate this database with vector embeddings from the transcript of our video. So our YouTube video is way over here someplace, right? We have the YouTube video, but we have to get the data into Chroma somehow. Well, that means we're going to have to write some more code. So we're going to have a separate Python program over here. Okay, and this feeds the embeddings into the Chroma database. Where did that Python program get its data? Well, it got it from the YouTube transcript. Okay, now we could theoretically use our language model as a way to handle this and build the transcript, but as it turns out, YouTube makes it easy to go download a transcript of a video automatically from their API. So this ends up just being a simple API call to get the transcript that we're going to feed into our first program. And this is the structure of our application. So we're going to start over here at YouTube, and we're going to push a transcript into a Python program that's going to organize it and get it ready to go into a Chroma database. And then the Chroma database plus the language model will combine in our next Python program, which is going to push the data out with the answers that we have to our questions. Make sense? Everybody following along? It's pretty awesome, huh? Let's see if we can take a look at some code now and see how it all actually works. All right, first things first, we have to install Ollama. This is the platform we're going to be working with. It gives you an easy way to download language models and connect them via LangChain to our code. We'll talk about what all those words mean along the way. But the short version is if you go to ollama.com, then you can download a Mac or Windows or Linux distribution of an application that runs in your background. And you can see I've got the little llama icon up here in the system tray. So that's a thing that needs to be active and running. And once you've downloaded it to your system and started it up, the very next thing you need to do is come to a command prompt and you type ollama pull and you give it the model name that you want to use. Now for the purposes of this exercise, we're going to use llama 3. So I'm just going to put ollama pull llama 3 and it runs. Now that went really fast. I'll open this up so you can see here. I have already downloaded this, so it didn't take very long. But for you, if you have a slow internet connection, 5 gigabytes could be a little bit. So you might be waiting on that. Just beware that these models are still kind of large to deal with. And depending on your internet speeds and things like that, you may have some concerns. But once you've got it downloaded, Ollama is now running that model in the background. It opens it up on a port, which you can actually see here in the code that's up in the background. Port 11434 is where Ollama is running. And so if we tell our Python app to go talk to Ollama, it can pull in whatever model is active there. But we're not going to start in the main. We're actually going to start over here in TubeScriber. Because if you remember on the diagram, we had two Python apps to worry about. There was the one on the one side that was going to get the transcript and feed it back into the Chroma DB. And then the other side is where we do the question and answering and linking everything together. So we're going to start with that first part about the transcription. And once we get the transcript in place and get everything rolling, then we'll be able to plug in the other side. So just a real quick look at this. YouTube gives you a fantastic interface to be able to pull transcripts and other things from the videos that you publish. So as I'm looking here, everything uses the video ID. So that is the back half of the URL. There's usually it's like youtube.com/watch or something, and then there's a string of alphanumeric characters. They sometimes have symbols in there too that uniquely identifies this video. That string is what you capture and pass into these things to make them work. So real quick, I've got a fetch YouTube transcript, which just calls the API and asks for the transcript given a video ID. And then I've got a formatter that cleans everything up just the way that I want it to display. And then I've got the overall transcribe method. So this is a Python class, and the only thing that you really use from the outside is transcribe. You instantiate the class and you feed the ID in and say, hey, transcribe this video for me. And it will pull down the transcript, and that's how you get it. So real quick, that's all it takes to get that part started. This is the first, so the icon that was over here when I was drawing earlier, this is the transcriber. Once that's done, we need to be able to feed it into everything else that's happening. Okay, so let's take a look at the rest of the app. We'll go over to main and see how this all comes together. So the first thing you'll notice, there's a bunch of imports. LangChain is a library that has lots of different features inside it. I'm only scratching the surface to pull in the things that are absolutely needed for a bare minimum RAG. But the API documentation out there is extensive. Make sure you dig around because it probably can do the thing that you're thinking about. Next, you'll see I've got a few global variables defined. So we're always using Llama 3, so I wanted to make sure that name was in there. It's running on my local box on port 11434, and the video ID. So if we were to go over to Shreya's website, to her YouTube channel, the video I pulled down is the episode 1 of her talking to Craig Dennis, and so there is the YouTube ID for that. So all of those things are now ready for us to use throughout our application. Invocations, we're going to skip and save for the very end. We're going to go straight down here to main, because this is where the real fun happens as far as building out a RAG app. So the first thing we need to do is make sure that we instantiate Ollama. So we need to tell the model, we need a model object to hold the model for us. And it's going to be pulled from Ollama, given the model ID, which was Llama 3, if you remember, and the base URL, which was the 11434 port thing. So all of that is now set up, and we now know in Python how to talk to a large language model. It's over there in the LLM variable. Okay, so the next thing we're going to do is we're going to pass this over to transcribe. You'll notice that I don't actually use the model here. I'm setting this up for later because I'd like to have the ability someday to not just pull from YouTube, but to use a local movie as well. So obviously you would want to use these kind of tools before you upload to YouTube, and that's where I'm going with it. But since I don't have that much content sitting around on my laptop right now, I wanted to be able to start with the YouTube transcript, and then we'll grow into the other. So I'm going to send this to transcribe, and that's what it's going to go do for me. It's going to go create the result and put it in the text field here. So this is either going to be a giant string with the entire transcript, or it's going to be an empty variable that says I couldn't open the transcript for whatever reason. So if the result is valid, if we got the giant string, we're ready to start building a vector store retriever. Now, a vector store retriever is a fun little thing to think about because it's kind of handling a couple of those boxes on the diagram at once. We're going to skip down here to where the vector store retriever is built and show you what's inside. So the result, this is what we passed in. So this is our giant string of text, and we want to pass this into the ChromaDB to create a database of the embeddings that we need, the vector embeddings, okay? But you don't just do that by sending a giant string at the embeddings system. You want to break it up into chunks first. And the reason we do this is because think about the way that you learn things. You learn things by associating small pieces with each other, sort of like Legos. In some ways you could think of it, right? That I have this concept and I have that concept, and when they come together, then that's where the thing happens that I go, oh wow, I understand something on a bigger scale. So we're going to do the same thing with the text. It doesn't understand a giant blob of text very easily. But if you were to break that text up into small chunks, which you can see here, 512 characters, and then we also establish an overlap. Now, why would you want the text to overlap? Well, think about it just in terms of like trying to maneuver through stuff. If you have something over here and something over here, and they don't touch, then you have to make a jump to get between them, right? Well, the same thing works with the text in a language model. As you build this model, you want to provide a little overlap so that the model, as it starts to understand the little bits and pieces of data, has context to say, oh, look, and this kind of relates to that at this one little point, and we see where it overlaps. So that overlap is what gives it the ability to establish intelligence and give you back much better results. It would still work to some extent if you didn't have overlap, but it's going to work better when you do have some, because it gives it the ability to then see the same, like that overlapped section, it can see that data from both points of view, and that changes the way the model interacts with it. So we're going to split our text up, and this is something that LangChain gives you an easy way to do. You don't have to think about it, it just kind of happens. And so you pass it to the text splitter and you say, make some chunks for me. And it makes all these chunks predefined. All you have to do is give it the size and the overlap amount, and then it's ready to roll. The other thing you need to build is an embed model. So this is where you're going to tell Ollama, hey, we're sending data back into the model to be able to create vector embeddings. And so you need that object that allows you to do that. And the reason you need it is because that's what you feed into the Chroma definition. So when you say, hey, Chroma, create me a database, you say, create it from these texts. So on one side, you have the chunks. There's the array of chunks that came back. And on the other side, you have the embeddings model. This is the way that you're going to embed that stuff. This is the algorithm you're going to use to define the vectors that we're going to use later. And that builds the Chroma database. Once you've built the database, you need to ask for it to be a retriever. And so this is what you pass back up here when we say, let's create a storage retriever. Now the store retriever is really important as we get to the final assembly, which is why I made both of those in one step. You could theoretically break this out into multiple steps, and probably you should if you have multiple data sources or other things like that going on that you want to consider. You'll probably have multiple retrievers that then have to be assembled into something further down the chain. But because this is a simple example and I'm just doing one shot, I kind of just smashed them all together and made it come back there. So the next thing we build is the chat prompt. So this is the template that allows the LangChain library to know how we're going to interact with the model. What's sort of the templated description of the conversation between us and the model. So we're using the Retrieval QA chat. This is predefined for us. It's part of the library. You can pull it in and you're ready to go. You can of course build your own custom if you really want to, but I'm sure the hub has a bunch of them out there you could choose from, so you don't even have to worry about it. For us, it's very simple. It's not even really conversational at this point because we're sending one request and getting one response. There's not the need to make that looping conversation, which we could add later, but for the purposes of what we're doing today, it doesn't really lend itself to that. Now, we're going to combine the docs in a chain. So a chain is this group of things that go together. So on the one side, we're creating a language model and a template chain that says we have this model, Llama 3, and we have the Retrieval QA chat template, and we want to put those together. We want to chain them together and then use that as another building block in what we're creating. So we're now assembling sort of that line from the LLM down to our Python code, if you remember on the diagram earlier. All right, now that we've built that chain, the other side we have to build is the retrieval chain that comes from our vector store retriever, which we built earlier. And we're going to combine it with this chain. So this is sort of that dot that I colored in on the diagram and said this is where they intersect. The language model and the ChromaDB both feed into this one point that now this retrieval chain is how our Python program knows to interact with the data. So the last thing we do is we call invocations and we pass it the retrieval chain that we've just built. This is how it knows what to do. So now we can go up to the top here where we talk about the invocations. So what is an invocation? Well, an invocation is just the name that I picked to talk about how we send requests to our language model. So the method name is invoke, and so an invocation made logical sense. And I'm putting a bunch of them in this one method just for demonstration purposes. So that's why I called it invocations. Now, in the invocations, you can see I've got several different things going on. The first is to create a summary of this message that's less than 800 characters long and add several hashtags that would be appropriate if this were the YouTube description of the video in order to maximize its social media outreach. So I'm asking the model in plain English, go build me the YouTube description field with appropriate hashtags for this video. And I just print it out to the screen. Of course, you could do other magic with this. Once you get the answer, you could have the answer come back in a scripting language if you wanted and pass that over to something else that would actually make other work happen. And that would be something we would explore maybe in a future video. We'll see. The next thing on the list here is to create a clickbait style title for the message based on its overall theme. So what's the title of this? What would I want to title my video to maximize the clickability? And I'll print out the answer it gives me there. And then the last thing is in the beginning stages of this idea of invoking other things and integrating with other products, locate at least 3 potential quotable snippets within the message that could make good short form video content. Provide me only the snippets, do not explain why you selected them. Now I added that last sentence because the first time I ran this, it stopped and gave me a full description of why it decided that these were the right ones to use. And I was like, I don't need all that. I just want you to give me the data and let me work with it. Okay, so let's see if we can get this code to run now. We're going to do Python main.py, and the transcription's already succeeded. We're now creating our vector database. This process usually takes 45 seconds to a minute, so I'll probably clip some of this down for the purposes of the video, but just be aware that this could take a little bit. A few moments later. All right, and now you can see that it's actually moved right along. It was about 45 seconds there. This is running on an M2 MacBook Pro, so just for reference, if you have bigger or smaller hardware than that, that should give you an idea of what you can expect there. Now you can actually see it started to give us our results back. The first invocation, this was the description field, if you remember right. The speaker reflects on their non-traditional educational path and how it has not hindered their ability to learn or grow. They share advice for those who feel they don't belong in coding, emphasizing that everyone feels this way and that each person brings a unique perspective. And let me tell you, that is Craig Dennis to a T. Absolutely amazes me that a language model can just read a transcript of a discussion and pull out that much insight. The hashtags that it's picked: coding for all, non-traditional learning, punk rock philosophy. I didn't see that one. I'll have to go rewatch the video to see where that came from. I like it though. Empowerment through technology, inclusion matters, coding community, and personal growth. And then I did a horrible job of formatting this, but you can see the title there. You won't believe what happened next. This guy's unconventional education story will blow your mind. I think that's a really good clickbait sort of headline to go along with what we're doing here. And then we've got 3 potential quotable snippets. Everybody has a posture syndrome, and now you're sharing. Okay, so on the surface, like, that quote seems a little weird because it misunderstood imposter syndrome, but it sort of understood it correctly despite the bad transcript. It actually understood what we were going for, and imposter syndrome is something that's really important to consider in this space. You're always going to feel like you're underqualified for what you're trying to do. But it did a great job of pulling out a quote there that If you wanted to go back and find that in the transcript and pull that to make a YouTube short, that's what I would use. That would be the TikTok that would lead you back to the video. I didn't deserve to be here, and like I could say that I wish I could go back and be more confident, but that's not something you can just be, right? Uh, Another great quotable snippet there that it pulled. And then you are coming with a unique life experience and you are needed. Um, if I had to summarize like everything I know about Craig Dennis, that's probably the statement that works the best for everything that I've ever thought about him. But just like that, a language model pulled this out of a transcript and made some decisions for us that help simplify our lives. So, how cool is that? So, there you have it. We've reached the end of yet another adventure of Blink, and we've gotten started with a RAG app. Retrieval Augmented Generation is incredibly powerful, and obviously you could go add features to this if you wanted. You could make it more robust, or you could make it evaluate its own responses to see if it's been hallucinating and does the response make sense before I send it out. You can keep adding on to this indefinitely. This is sort of the most basic building block of the AI developer's toolkit. So now it's your turn. I can't wait to see what it is you're going to go build with this. And I would love for you to share. So send me a PR, uh, throw a link in the comments to whatever it is you're working on. I'd love to share notes and collaborate and just have some fun together. Take care, friends.